Well, hello and welcome to our study guide review, study guide requests. Every single problem that I'm working out today was requested personally by you guys, wanting to know how to do them, how to solve them, how to explain them. So we're going to jump right into it. A little dark in here, but that's all right. I'll try to see if I can cut back on the contrast a little bit. Yeah, that's a little better. Yeah, wow, it's still dark. Anyway, here we go. So as I'm looking at these requests, there's only one that came from equations on both sides. So here we go. Pulling up the problems. Why won't this work? There we go. Sorry. Okay, so the request came from problem number one. Okay. Well, there it is in all its glory. Okay, so here we go. To solve problem number one, there are four different options here. So whether you wanted to take away 6r from both sides, you could start it that way. Or maybe you want to take away 7 from both sides, you could start it that way. Or maybe you want to take away 13 from both sides, you could start it that way. Or maybe you want to take away 7r from both sides, you could start it that way. And the reason any of those ways make sense and work is because of our goal. Our goal is to move all r. Is to move all of r to one side. Move all constants to the other side. So constants are the whole numbers that don't have variables. So those are our two goals. So that's goal one, and that's goal two. So me personally, when I look at this problem, I like to deal with the variables first. So I'm going to take away 6r from both sides. So what do I have left? Well, these cancel. So I'm left with 7 equals 13. 7r minus 6r is just plus 1r. Okay. So move all the r's to one side. Check. Did that. Now move all constants to the other side. Okay. Well, constants are the numbers without variables. So I would have to take away 13 from both sides. I think we can do a better 3. And what do we end up with? 7 minus 13 would be negative 6. 13 minus 13 is 0. So we have just negative 6 equals r. So that would be the value for r. Did I move all the constants to the other side? Yep, I sure did. So rewind and rewatch. That's the only problem that was requested from equations with variables on both sides. Okay. So moving right along to the other document. Okay, so solving systems with substitution. Let's see. Looking at the requests. We got problem number 1 was requested several times, so we'll go ahead and handle that first. Okay, so here we go. It's gonna work out. Okay, so if y is equal to all this stuff, and there's a y in this second equation, we can rewrite this as negative 2x minus 3y, but instead of saying y, we'll put parentheses. We're going to put everything that y is worth, which is 6x minus 11. So negative 2x minus 3y equals negative 7. Okay, so let's see what that turns into. Okay, so the first thing we're going to do is the distributive property right here. So that's negative 3 times 6 of minus 18x. And negative 3 times negative 11 would be positive 33. And that's still equal to negative 7. Okay, so now it looks like I'm going to be combining some like terms. So negative 2x, negative 18x, they both have the x variable. So negative 2 minus 18, so that'd be negative 20x plus 33 equals negative 7. Okay. I have no more like terms, so if I were to do the opposite, if I was to subtract 33, remember we're trying to get all the constants onto one side now. I take away 33 from both. What do we get left with? We're left with negative 20x plus 3 minus 33. They cancel out. Equals negative 7 minus 33 would be negative 40. So the last step, you divide both sides by whatever is stuck to the x, which in this case is a negative 20. Negative 40 divided by negative 20. So x equals 2. These make 1x, and negative 40 divided by negative 20 is 2. But we're not done yet. So now we take that. And we can plug it in for this x, or to be honest, we can plug it in for this x as well, but I think the top one looks simpler. So the y equals 6 times 2 minus 11. Pardon me, so what's 6 times 2, chat? Well, 6 times 2 is 12. And 12 minus 11, so y is equal to 1. So our actual combined answer would be x is 2 and y is 1. And what that means is that's where these two lines intersect. That's where the two lines crisscross each other. Okay? Okay, so that was substitution number 1. That was the number 1 most requested problem. Let's see. Next one would be number 7. And I think 7's special. I think 7's the first time where y and x don't have an explicit value yet. Yep. Okay, so with this one, there's a little bit of extra work to do. We need to take, okay, so let me get up my chat box again. Okay, so number 1, get a sentence to say y equals to stuff, or x equals stuff. Second goal. Then we'll go ahead and do the substitution. Then we will solve for first variable and for use to find the other variable. Okay, so that's what we're trying to do here. And this might be true for the other. That's why I went ahead and typed it out. Okay, let's see, make this a little bit smaller. Yeah, that's better. All right, so let's see if we can do that. I think, okay, so it really does not matter which one you choose. I'm going to go ahead and take this top one. Experience tells me this one's going to be a little bit easier. So this one says negative 4x plus 1y equals 6. But I know that if we were just to, I don't know, add 4x to both sides, these would cancel out, and you'd end up with y equals 4x plus 6, because they can't combine the 4, 6, and the x. They cannot mix. And one of them has a constant, and one of them is a constant, and one has a variable. So they just can't do anything about it. So, okay, so now what we've done, okay, get a sentence to say y equals stuff or x equals stuff, check. We've done that. Okay, substitution, okay. So let's go ahead and take this y equals 4x plus 6 and plug it in right here for this y. So that'd be negative 5x minus, and then here's where we need to put in the y, 4x plus 6. Okay, there's the y. So it's negative 5x minus the y equals 21. Okay, so check. We did the substitution. Got it. Okay, solve for the first variable. Okay, so that'd be negative 5x. Now, chat, this negative symbol, think of that as being a negative 1 on the outside of the parentheses. So negative 1 times 4x be negative 4x. Negative 1 times x be minus 6. Okay. So negative 1 times those. Basically, the signs just flip around from positive to negative. Okay, next. Combining late terms. So I've got this negative 5x, this negative 4x. That means negative 9x minus 6 equals 21. So I guess what we could do, we could add 6 to both sides. So we'd end up with negative 9x equals 27, which means if you divide both by negative 9, you always want to divide by the coefficient. That's the number stuck to the x. If we divide by negative 9 on both sides, we're going to get x equals negative 9 divided by negative 9 is just 1x. 27 divided by negative 9 would be a negative 3. Okay, so now that we have, so solve for the first variable, check. Now use the solve variable to find the other variable. Okay. So now that we have x equals negative 3, we can use it right here. Or, I mean, either one of these would work. Which one looks easier? Maybe the top one. It's like negative 4x, which we found as negative 3. Okay, so Negative 4 times x, negative 4 times negative 3, plus whatever y is going to be, equals 6. So that'd be negative 4 times negative 3, that'd be 12. Plus y equals 6. Okay. So next, as weird as it's going to look, we already have the y on the left side, so we're going to divide both. We're going to actually not divide, duh. We're going to subtract 12 from both sides. And then, let's see, y would be negative 6. That was a horrible box. Hang on. I just draw one like this. So y is equal to negative 6. Because 12 minus 12 is 0, and 6 minus 12 is negative 6. Okay. So apparently our big coordinate is at, so this is negative 3 comma negative 6. Okay. So that's how we solved, and yeah, we did that. Okay. So that was problem number 7, which was requested multiple times. All right, now we're going to look at problem number 9. I don't want to lose the goals text, so I got to delete this other stuff. Okay, so let's see. Let's scroll. Okay, so here's number 9. Perfect. Park it right there. Awesome. Okay, so let's see. Set something equal to y or something equal to x. I think this top row looks better because I can see this y all by itself. So what if we if we added 5x to both sides, what it would turn into it'd be negative. Oh, I'm sorry, that'd even go away. Blah. Blum, blum, blum. So that'd be y equals 5x minus 2. Check, because we found out what y is equal to. So we added 5x both sides, get this to cancel, and then 5x minus 2 is what's left over, is y equals, okay. So now we're going to take this, because it's equal to y, and plug it in right here. So that would be negative 3x plus 6y, but instead of y, we're going to put this stuff y is worth, which is 5x minus 2. Negative 3x plus 6y, y being 5x minus 2, and parentheses equals negative 12. Okay. So distributive property. First thing, it's just screaming at me to do. So I'm going to keep the negative 3x. But 6 gets multiplied by both terms on the inside. So that'd be a 30x, so plus 30x. And then 6 times 2 is 12, so it'd be plus 12. Equals a negative 12. Okay, so combining like terms then. So if there's negative 3x and this positive 30x, that'd make 27x. I still have this plus 12, and I still have this negative 12. Negative 27. I feel like checking my work real quick. Let's see. So y equals 5x plus 2. I mean minus 2. Check. That should be a minus, so negative 3x. Back it up, back it up, back it up. Always go through and check your work. Me and my negative symbols lately have been really sketch. Okay, so let's go back to this. So y equals 5x minus 2. So that'd be 5x minus 2. So 6 times 5x would be 30x. 6 times that, though, so negative 3x, 6 times 5x is 30x. 6 times negative 2 would be negative 12. Okay. So negative 3x plus 30x will still be 27x. Just running the whole problem through my head as I go, double checking. So y equals 5x minus 2. Negative 3x plus 6y. Yep, okay. Everything seems to check out. Minus 12 equals negative 12. So what happens when we add 12 to both sides? And this is what made my brain go back and check everything. So I could see this coming, and I just wanted to make sure I was right about it. So if you add 12 to both sides, what happens? You end up with 27x equals 0, which is fine, because if ever you have this situation, something x equals 0, and then you decide, well, I don't know, what would happen if I divided both sides by 27? So x equals 0. At least it should be. We can check. And if I messed up, I'd be happy to fix it. Problem 9. Yep. If you're not scrolling down to check your work, then I don't know what you're doing. Okay. So now if x is 0, we get a different, very easy to see color. Okay. All right, so x is 0 right here. So we just need to plug that in. Like, here's the simplest sentence we made. So y equals 5x minus 2, 5 times x. We found out x is 0 minus 2. So what's 5 times 0? Y equals 0 minus 2, so y must be negative 2. So 0, negative 2, and the way you just check that, you just scroll down. Y equals negative, oh, come on, 0, negative 2 should be for 9. There it is. Okay. Next request. So that was, we've done 1, we've done 7, we've done 9. Looks like we've got 2 more. The next one, which was requested by multiple people, is number 10. So I need to scroll sideways for this one. There it is. So we've already got the answer in front of us, which is fine. I'm just going to prove that that's correct. Okay, so let's rewrite this one. So if I were to add 5x to both sides, that would make this into y equals, those cancel. So y equals 5x minus 3. Sure, that's fine. Y equals 5x minus 3. So then we can take that and plug it in for this y right here. So what do we get? So this becomes 3x minus 8 times whatever y is, and that's 5x minus 3, equals 24. Okay, so let's do some distributive properties. So that'd be 3x negative 8 times 5x. That'd be minus 40x. Negative 8 times negative 3 would be plus 24. Negative times negative is positive. And then this equals 24. 3x, negative 40x, plus 24. Yep, everything seems fine. So 3x and negative 40x. That's going to make negative 27. No, 37. Negative 37 because 40 minus 30. Negative 40 has so much greater of a magnitude. That means I know the answer is going to be negative. The difference between 40 and 3 is 37, so that's negative 37x. So we still have plus 24 equals 24. And this is going to have something similar to the last problem I did. What happens? Whoops. What happens when we subtract 24 from both sides? It becomes negative 37x equals 0. And that's fine. I don't care, because when I divide both sides by negative 37, well, 0 divided by anything is equal to 0, so this just equals, let me say x. Anyway, we've been solving for x this entire time. Let's see. So x equals 0. And we can confirm that over here. Okay, check. So then we take that. To be honest, our easiest equations up here with the one we made, y equals 5x minus 3. So y equals 5x minus 3. We wrote that. So let's use x equals 0. So y equals 5 times 0 minus 3. So y equals 5 times 0 is 0. Okay, so y equals just negative 3. There it is. So that is solving for number 10. Last problem, everybody. And that's all the requests that I got. Double checking it. The last one, but it was requested by at least two different people. It's problem number 18. We'll go ahead and keep the answer ready too. All right. So let's see what happens. Okay, so as soon as I see this, I realize, yeah, you got to really manipulate this one. So here's one we're going to be working with. So I've got negative 2x plus 6y equals 6. Now, I just noticed, because I've done it so many times, that there is a way to get this simplified. Notice how each one of these things is even. So why don't we just divide every single item by 2? We are respecting the equal sign because we're dividing everything by 2. So what would we get? Would that be negative x plus 3y equals 3? Okay, negative 2 divided by 2 is negative 1. 6 divided by 2 is 3. 6 divided by 2 is 3. Okay. Now, what we can do is we can divide everything by negative 1. So this would become x. Negative 3 divided by, so this would become minus 3y. This would be negative 3. So we just took that pink sentence, negative 2x plus 6y equals 6. We did some simplifying, and now what we can do what if we added 3y to both sides? So these cancel. we have x equals 3y minus 3. Okay, so we just check. We divide everything by 2 to make sure, to simplify. We divide it by 1 to make it x minus 3y. Okay, we're getting x by itself, basically. Then we added 3y to cancel it out to get everything on the other side. So we got x equals stuff. Okay, so now we should be able to put that in for one of these two. I'm going to take the bottom one. So this would become, so negative 7 times whatever x is. And we figure that's 3y minus 3. Negative 7, 3y minus 3. Okay, so that's what we found out for x. Okay, so did that. Plus 8y equals negative 5. Okay. Okay, so let's do the distributive property real quick. So negative 7 times 3 would be negative 21y. Negative 7 times negative 3 would be plus 21. And then we get plus 8y equals negative 5. All right, combining like terms, we got a negative 21y and a 8y. So one's positive, one's negative. So the one that has the negative value, the negative 21, has a greater magnitude. So I know my answer is going to be negative. So what's the difference between 21 and 8? 13. So negative 13y, maybe? Plus 21 equals negative 5. Interesting. Okay, so what if we subtracted 21 from both sides? Where would we be? Be negative 13y equals negative 26. Yeah, that's pretty compatible. So we divide both sides by negative 13. So these cancel, so what are we left with? Negative 26 divided by negative 13 is just 2. So there's the 2. And we already found out that x was equal to... Wait, hang on. Was that just now? No? Okay, so we've solved for y equals 2. We haven't solved for x yet. But we can take this real quick and put it in here. So that'd be x equals 3 times 2. So 3 times 2 is 6, minus 3 is 3. Yeah, 3 times 2 is 6, and 6 minus 3 is 3. So we've got the y value and the x value. Okay. Well, please, look at all your other study material and pause, rewind. If you have other requests, post them on the assignment. I'll check it every day, and maybe I'll put more content up if you have a chance to study, that is. All right. Well, until next time, Mr. Matthews signing out. If I can find the button. All right. Bye, guys.